All right, so this is going to be a video with some example problems for reverse power rule. Okay, so this first one here is a pretty basic one. It's usually the first one you see, x squared. So we're doing the antiderivative of x squared here. If you remember, this and this together mean antiderivative of whatever's over here. The notation's kind of funky. It's almost like the outside going in for this, but it's the antiderivative of x squared. So using reverse power rule, we would add 1 to whatever the power is that's originally there, and then divide by whatever that power is. So that's always going to match. This 2 plus 1 is going to show up as the power, then it's going to show up as what you're dividing by. And then you need a plus c because it's the antiderivative. Let's clean this up a bit. So you end up with x to the third over 3 plus c is your answer. And you can, if you wanted to, check your work by doing the derivative of this. You bring the 3 down, you minus 1 from the power, and then you add the derivative of this constant here, which is 0. You're still dividing by 3 as well, so you're going to need that in there. Okay, and if you simplified this, 3's would cancel. 3 minus 1 is 2. X squared plus 0 is just x squared, which is what you started with here, so you know that this checks out. It's a good idea to do that. Just do the derivative like normal on your answer. For the antiderivative, you should get back to where you started. All right, the next one's a little tricky, but not really. First thing I'm going to do is take that constant multiple and put it to the outside. It's with respect to x, so this 3 we can just kind of move out here. So that's what I did. It just cleans it up a little bit more. All right, one thing I noticed is that it doesn't look like a power function. It needs to be x to the n. So what I'm going to do is rewrite it so it's in the form of x to the n, so it's x to the 1/2. Now you can do reverse power rule on this, and you end up with 3 times x to the 1/2 plus 1 divided by 1/2 plus 1 plus c. Okay, this can simplify, of course. This ends up being to the 3/2. This ends up being to the 3/2. And now when you're dividing by 3/2, it's the same as multiplying. So you're just by 2/3. So you're just multiplying this 3 right here by 2/3, and you're going to end up with 2x to the 3 over 2 plus c as your answer. Now if you wanted to, you can do the derivative of this. All right, so you bring the 3/2 down, times the 2, and then you have to minus 1 from the power here, plus the constant derivative, which is 0. This simplifies here. 3/2 minus 1 is 1/2. So you end up with 3x to the 1/2 plus 0. That doesn't actually matter. And if you notice, this 3x to the 1/2 matches where you started. So you know that this actually checks out. All right, next we have this problem up here, the antiderivative of 1 over x squared. Okay, again, I'm going to rewrite this as a power, so it's a little bit easier to work with. Now remember, 1 over x squared is not the same as x squared, so this problem is going to look different. You should have a different answer since the functions are not the same. I'm going to rewrite this so it's a power function, so it's x to the n. The n in this case is -2. We're going to add 1 to that power, so -2 plus 1, divided by that whatever that power is, so that matches, plus c. And if you notice this in this match, it's always going to happen. Okay, and then from here, I'm just going to simplify, so it's going to be x to the -1 divided by -1, because this right here is -1. I'm just going to put a negative in front, plus c. Okay, again, good idea to check your work on this, so let's check the work here. We're bringing -1 down, so you're going to have negative, which is positive. So you're going to have x to the -1 minus 1 plus 0 when you're checking this. And you end up with x to the -2 plus 0 cancels. This ends up being -2. That's where the -2 comes from. So this checks out as the answer. All right, the last one is kind of a trick, so try not to get tricked on it. The antiderivative of 1 over x, if you rewrite that, it's x to the -1 dx. Okay? Trying to do power rule here, you're going to end up with x to the -1 plus 1 over -1 plus 1 plus c. But this leads to a problem, because now you'll notice that you end up dividing by 0 here. You can't divide by 0. This antiderivative does exist, but it's not equal to something divided by 0. This is not intuitive, so I'm just going to write this in here now, but there is going to be a separate video explaining where all this comes from. The antiderivative of 1 over x is actually ln of the absolute value of x plus c. Okay, again, we're going to cover that in another video. I just felt like showing it now because it's kind of a good example, and it's also something that trips up students a lot. They end up with something divided by 0. They think it's 0 or something like that. You can't divide by 0. So essentially this defines a new function, this ln x plus c. But again, we'll talk about that more in a different video. So that's basically some example problems using reverse power rule. If you have any questions about anything in this video, let me know.